Okay, welcome everyone. Mr. Allen here. I'm going to go over some of the questions from section 1.5 where we're combining our combinations and permutation type questions. So here we've got kind of an old question, I guess, 2004, 2005. How many ways can they select the championships? Essentially, we're looking at the 6 different universities to host the championships, and they are not to be held at the same university. So we can sort of think of this as the first year that we're interested in, and the second year we're interested in. There are 6 choices available, or 6 possibilities available here for 2004. Once that university has been picked, there is no opportunity for them to be picked again, and so there are only going to be 5 possibilities for the second year. And if we multiply those, we get 30 different possibilities. If they can both be held at the same university, that's pretty straightforward. There are 6 possibilities for the first one, for the first year, 6 possibilities for the second year. And once again, because it's an and situation, we need a first university to be chosen for the 2004 championships, and we need another university to be chosen for the 2005 championships. Now I say another, but it could be the same one. We need a second choice, though. We have an and situation. 6 times 6 is 36. Question 2, I think, is going to be the same. How many ways can judges choose a winner and a first runner-up? Not sure why I can't unhighlight those. So we basically got, we're looking for the first place person and the second place finisher. There are five people available. Once one of them is chosen as the winner, there is no possibility that they are also second place. And so once again, 5 possibilities for the first place, 4 remaining people available for second place, 20 overall. So those ones were pretty straightforward. We're getting a little bit more complex now in question 3. Not terribly, but we have mayor, treasurer, and attorney available. So we're going to have different values for each of these. Once again, the question asks basically how many different possible ways can I mark my ballot if I'm going to vote for all 3 of these different positions. Well, there are 5 people available to vote for here. Oh, sorry, that's not true. There are 4 people available for mayor, 5 available as a city treasurer, and 2 available running for the county attorney. Multiply those through, 40 possibilities in the first case. In the second case, the question just changed a tiny bit and say, well, if we exercise our right not to vote, so I'm giving myself the option to not vote. And often this is a question that confuses people, but really what it does give me is just 5 possibilities for mayor. I could choose to vote for any one of the 4 people that was on the ballot, or I could decide to not mark the ballot. So now there are 5 possible mayor selections that I could make. Similarly, there will be 6 possible treasurer selections and 3 possible attorney selections. And so that's 30 times 3, 90 possibilities there. Keep going. Multiple choice test consists of 15 questions, 5 options. Okay. So this one's going to be a little different. We can think of it as question 1, question 2, question 3 along the way, question 13, 14, 15. And I have 5 choices, A, B, C, basically A to E, and so on, every step of the way. The key, of course, is whatever question 1 or whatever answer I come up with for question 1, and there are 5 possible differences there, does not affect question 2 in any way. So there will be 5 possible differences there, or 5 possible selections there. And again, I could choose anything from A to E all the way across And so there are 5 times 5 times 5 times 5, or 5 to the 15 possible selections there, which I don't know off the top of my head. I'm actually reading it off of another page. Is 30 billion 515,000. Nope, 517,578,125. That's why we have calculators. Television director, so 6 available slots. I've drawn them out to sort of save a little time. How many ways can the director schedule? So 6 different commercials. Now we can sort of think of this as commercial A, B, C, just to sort of have something, again, to label. In time slot number 1, we could have any of those different options. We could have commercial A, commercial B, and so on. And so there are 6 possibilities there. Once that commercial has been played, of course, it is not going to be played again in slot 2 or the subsequent slots. And so we simply have a regular permutation here. Good old 6 factorial, which is 720 different possible ways to arrange those commercials. Now, these later questions are a bit more interesting. We can think of them in 2 different ways. The first way, pretty straightforward. I've got those same 6 time slots, and I'm going to be placing, what does it say, 3 different commercials. So basically I have commercial A, commercial B, and commercial C, but I have to use each one twice. And so I can sort of think of it in terms of these are the time slots available. Commercial A has to be basically placed into 2 of those time slots, and then commercial B into 2 as well. So I'm going to actually slide this out of the way because I'm not going to use it in the way I traditionally have. I'm going to think of it as there are 6 time slots available for commercial A, and I need to choose the 2 time slots that we're going to make use of. Once those 2 slots have been chosen, whichever slots they were, commercial B will have 4 available time slots remaining, from which we have to choose 2. And then technically, commercial C will have 2 remaining time slots, from which we have to choose 2. But by now, hopefully, we recognize that if there are 2 items and we have to choose both of them, there's only one way for that to happen. I'm just going to take the remaining 2 slots. And so in the solution set, I don't bother putting this in because it doesn't really affect anything. 2 choose 2 is just the number 1. And if we multiply that out, we end up with the value 90. Now again, that's one option as to how to think this through. I'm going to knock this down. I could also think of this as a more traditional permutation question. It's permutation with duplication. In the original question, when I had 6 different time slots, I had 6 factorial ways to solve the problem, or sorry, 6 factorial ways to arrange my commercials. Now I have that same 6 factorial. Oh, but wait a minute. I have A in 2 different slots. I have 2 different A's, I suppose. You could sort of think of it as this is my set of letters or set of commercials to place. And so I need to divide out the duplication caused by the 2 A's. But wait, I also have duplication caused by the 2 B's. So I have to divide by that as well. Oh, wait a minute. There's duplication by the C's as well. And shockingly, if I punch 6 factorial divided by 2 factorial divided by 2 factorial and divided by 2 factorial into my calculator, I get that same number 90. So both of these are perfectly valid solutions, just depending on which way you want to think them through. And I think we'll find that with the next 2 as well, or at least one of the next 2. C sounds pretty similar. Yeah, it is. And so once again, extend this page. I can do pretty much the exact same thing I just did. Option 1, I can think of it as there are 6 time slots available. I need to choose the 3 for commercial A. And then once again, if I did have 6 slots available, once A has been placed in whichever of those spots it's going to take up, you can sort of see I don't have any choices really left over. So technically, commercial B has 3 slots available. We need to choose those 3 slots. But again, this is just the number 1. So I'm technically multiplying 6 choose 3 by 1. And 6 choose 3 is just the number 20. If we think it through in the second method, once again, pretending like we didn't know there was any duplication, we would have 6 factorial options, dividing that 6 factorial by, oh, wait a minute, the 3 versions, the 3 commercial A's, oh, and the 3 commercial B's, gets me that same number 20. So again, the key there is if there were no duplication, I would have 6 factorial ways to arrange things, just like in the first part of the question, or part A. But because of the duplications, I do have to divide those out, knowing that if I swap commercial A with another version of commercial A, I don't really get a different arrangement as far as the commercials go. And last one here, if the sponsor has 3 different commercials. Okay, so basically we're going to have a 3-2-1, so you can sort of think of it as this kind of a situation. Once again, I've got a couple of different ways to think it through. There are 6 time slots. I need to choose the 3 where I will place the A commercials. That will leave me with 3 remaining slots, 2 of which I have to choose for the B commercials. And then again, the last remaining spot, I could write it down as 1 choose 1, but as we know, that is not necessary. And so this ends up being 60 different ways to work those out. In terms of the second option here, once again, pretending like we don't see the duplication, 6 factorial, but wait, I need to divide out the A's, and I need to divide out the B's, and again, 60 at that point.